iPRSM. From design to audit to proactive management of change, iPRSM brings unprecedented accessibility, accuracy, and efficiency to pressure relief systems management. Welcome to Systems and Revisions in iPRSM. This video describes the protected system model that lies at the heart of iPRSM operations and illustrates the processes of protected system construction and management, including the use of system revision control to organize workflow and to archive system data. Part 1. Protected Systems. As described at iPRSM.com, the protected system model is a point of focus that distinguishes iPRSM from its competitors and elevates it above other pressure relief management solutions that start with the relief device and work backwards. iPRSM instead derives the relief requirements of a system and then works towards identifying the relief devices that can provide that protection. In iPRSM, sites contain plants, plants contain units, and units contain systems. Using the protected system model, iPRSM works through the various system components, the overpressure scenarios, thermopackage, linked equipment and ancillary, OVP, and protected roles, and piping and fittings to calculate minimum required protection, and then finds relief equipment that can assure adequate system protection under all applied overpressure hazard contingency scenarios. Here is the P&ID drawing of a unit in a process facility. These are its protected systems, bordered in green and magenta. And here are the relief devices that protect those systems. One unit, two systems, each protected by a different pressure safety valve that can provide adequate protection to that particular system under all contingency scenarios that apply to the system. In the iPRSM software, protected systems are managed through two main pages, a systems browser and a system view. First, the systems browser. Accessible at the unit level and wherever else the Browse Systems option is available, the Protected Systems browser can be used to view, search, and sort protected systems both within a plant and in a selected unit in a plant. For each system in the Protected Systems browser, you can pick links to navigate directly to protected systems, relief devices, protected equipment, and current revisions. Pick icons to access uploaded graphics, documents, and protected system reports. Picking a drawing link here takes us to the system sketch for the protected system. With a control valve in an ancillary role, vessels as potential overpressure sources, a heat exchanger that requires relief protection, and a relief valve that provides that protection. This sketch was uploaded to iPRSM, and the image map editor was used to turn a simple graphic into a link map from which we can navigate directly to the equipment view for each piece of displayed equipment. The iPRSM image map editor is fully documented in the iPRSM handbook. If we wanted to add a new protected system, we'd pick the Add System link here. For instructions on that procedure, see the Introduction to iPRSM video. In this video, we'll look at an existing system. The Protected System view is a hub where all system components are brought into association and displayed. Pieces of equipment are linked to the system, compound streams are added, and contingency scenarios are applied. Here we see the four roles in which equipment can be linked. Relief equipment protects other system equipment by relieving overpressure under specified conditions. Protected equipment is equipment that requires such relief protection. Equipment can only serve a protecting or protected role in a single protected system. There's no such limitation on equipment in OVP source or ancillary roles. An OVP, or overpressure source, is any piece of equipment that may cause an overpressure condition. Proper protected systems design requires taking every potential source of overpressure into account when specifying relief devices, so that as a plant evolves and once impossible overpressure scenarios become plausible, systems that require review and adjustment will be easy to locate and correct. Ancillary equipment is any piece of equipment that can affect the pressure or flow in a system. The linking of overpressure sources and controlling ancillary equipment, like upstream relief devices and control valves, ensures that, as changes are made throughout the life of a plant, overpressure protection roles can be properly reviewed and easily updated. Compound streams can be added to a protected system from the System View's Compound Streams table by picking an Add Under icon. In the Compound Streams view, compounds can then be selected and composition configured. And stream flashes can then be added to the compound stream. Once streams and flashes have been added to the protected system, Fluid phases can be linked directly to contingency scenario evaluations in the contingency scenario views, accessible from the last table of the protected system view. Individual overpressure hazard contingency scenarios can be added at any location by picking an Add Under icon. Alternatively, all contingency scenarios defined for a plant can be added to a system in a single process by picking Add All Standard OVPs, and then selecting or deselecting defaults for notes and applied status and confirming. We'll turn off the default notes for now and show how to add them later. In typical workflow, all standard OVPs should be added, and then decisions should be made to apply or not apply each scenario in evaluations of the current protected system. Scenarios that do apply need to be individually configured to the current system. This is achieved by navigating to the contingency scenario view for each one. If they aren't selected by default, here we would specify overpressure, hazard, and flow types. It is particularly important to enter a unique identifying extension string when other scenarios of the same type may be applied. Next, we designate additional contingency scenario elements, such as which linked equipment participates or contributes in scenarios for which they apply to the overpressure and hazard types, discharge evaluation zones for header analysis, and fluid phases from the compound streams. The streams and flashes we looked at earlier are available on the menus of the Fluid Phases selector here. Next, we enter the scenario's parameter values. The scenario view also includes a notes field where additional documentation can be entered. Piping losses normally need to be calculated and evaluated for each scenario once the scenario's required area has been determined, but that is for another video. If Apply was not selected by default when the scenario was added, it can be selected here. Scenarios can be evaluated individually, and all applied contingency scenarios are evaluated whenever a check system operation is run. When a scenario is evaluated, iPRSM uses the entered data to derive the orifice area, ASME. Calculation of this value is the essential function of the contingency scenario view we're looking at. Notes for scenarios can be entered individually in the contingency scenario view, or in batches by picking the scenario notes link to access the scenario notes page. Scenario notes should be time-stamped using the clock icons and should contain the engineer's logic and assumptions for each scenario. iPRSM provides standard notes for each standard scenario type, which can be entered for scenarios individually using the pick card icons, which open note selectors, where any of the standard notes for a scenario type can be selected, and then any blank information in the note filled in. One standard note will also be designated the default note for each standard scenario. These default notes can be entered for all scenarios at once in a single operation. All standard scenarios, whether applied to a given system or not, must be fully documented in their notes fields, and this can easily be accomplished and checked on this batch notes page. For scenarios that are not applied, why a scenario can be left out of evaluations of system protection needs to be fully explained. As we've said, the protected system is a hub into which equipment is linked in specified roles, compound streams are added, and contingency scenarios are applied in order to assess the adequacy of the equipment protecting the system. Once each of these components has been brought into association, the protected system can be evaluated for adequate protection, and its status can be advanced. When a system is under construction or has been changed in any way, its status will be open, and the check system and mitigate system links will be enabled. Picking the check system link and confirming sets a complex operation in motion. iPRSM will check all applied scenarios and their piping losses, and then check orifice areas and inlet and outlet piping losses for all relief devices. A more detailed description of the check system process is available in the iPRSM handbook. If required data is incorrect or unavailable, calculations cannot be made and workflow is blocked. The check system operation is terminated, and iPRSM returns critical messages in red, and the sign-off link is not enabled. When a system is open and cannot be checked or signed off without some form of mitigation, the system can be flagged by picking the mitigate link, at which point the current system revision would probably be queued for those tasked with the mitigation. Once mitigation is complete and the system can successfully be rechecked, the mitigation flag is automatically turned off. It can also be turned off manually from the Other Functions dropdown. We'll assume that mitigation has been completed and check the system again. If the check system operation encounters no problems and no critical messages are returned, the system status will change to System OK, and the System Sign-Off link is enabled. Picking the System Sign-Off link stamps the system with your username and updates the system to status checked. Part 2. System Revisions. Protected Systems workflow is managed through System Revisions, and System Revisions are managed through 5 different iPRSM pages: a revision view, a send mail page, a reports package view for revisions, a revisions browser, and a revisions batch editor. As we've just completed some work in the protected system view, a natural next step would be to advance the stage of the current open system revision, or queue the system revision for another user, or send out email notifications regarding the work that's been done. For each of these tasks, we would navigate to the revision view, accessible through revision number links wherever they appear. Revisions are identified by their number, which can be edited. If appropriate, a due date for the revision can be entered, and the revision can be queued for a specific user. Queuing causes the revision to appear in the workflow page of the selected user. To set the revision stage, select a stage from the drop-down, and then pick Change Stage to confirm. Note that the list of stages roughly follows the standard workflow for a system revision. From New and Assign, to Design and Engineer, to Prepared, Approved, Submitted, and finally Accepted, whereupon a revision would typically be closed. Note also that Submitted and Accepted are starred. If either of these stages is selected, the system is locked. Locked systems are read-only. No changes can be made to locked systems until their revision is moved to a stage other than Submitted or Accepted. A system can only be edited if it has an open revision in a stage that is not starred. When a new system is first added, iPRSM automatically assigns it a new open revision so that the new system is open for editing. Picking the Send Mail link takes us to a mail function, where current revision details are conveniently autofilled in the outgoing message, which can be dispatched to one or more iPRSM users, including recipients not in the system. iPRSM also includes an attachment feature for including documents with the outgoing mail. The Revision Control view also offers fields for entering notes pertaining to the revision, which can be stamped, and pertaining to a system audit, which can also be stamped. As a system revision progresses through various stages, its history will be displayed in the Current Revision History panel. Picking the Generate link takes us to the Revision Reports package view, where a custom or standard set of reports related to system components can be generated and saved to the current revision. For a demonstration of this functionality, see the video Generating Reports in iPRSM, Part 2. Back in the Revision Control view, and after a reports package has been generated, the package can be viewed or downloaded directly. To close a revision, pick the Close Revision link and confirm. Until a new revision is added to a system, the most recently closed previous revision can be reopened. Reports packages that have been saved with the revisions can always be accessed, viewed, and downloaded. And so iPRSM can store a complete archive recording the state of a protected system at every revision in its history. When there is no current open revision for a system, the Add Revision link appears. Pick the link and enter a revision number to initiate a new system revision process with a new open revision. For a top-down look at all system revisions in a plant, or in a unit within a plant, iPRSM provides a browser for system revisions, accessible from the Protected Systems browser. Select No Unit to browse revisions in all units in a plant, or look only at those in a selected unit. The Systems Revisions browser allows you to search and display systems by their system name or status, revision number, status, or revision stage or queued for user. These query controls could be used, for example, to view all revisions that are submitted and awaiting acceptance, or have been queued and are awaiting approval from a particular person. Like the browser for systems, the browser for system revisions provides quick access to protected systems, their relief devices, protected equipment, current revisions, and any uploaded system sketches or documents. Lastly, iPRSM features a batch editor for system revisions. Available from the Revisions browser or the Systems browser, the Batch Revisions editor allows you to make standardized changes to system revisions within a plant, or a selected unit, or to a subset of selected system revisions. Use the checkboxes to select the type of update, and then enter or select the update details to standardize revision numbers, stages, staged or due dates, queued for user, or revision and/or audit notes. You can even close or open active revisions for all selected protected systems at once. Search drop-down menus allow you to search system revisions by the system or revision status, the revision stage, or the queued for user. Pick the Show Plan link to view in advance the effects of the changes you've selected. Afterwards, you can pick Show Current to look again at the current state of system revisions. To demonstrate, we'll open New Revisions for all systems, and set all revisions to the number 1.4, and put them into the stage design. But we won't perform this change on any systems of status submitted or higher. Picking Show Plan displays the updates in red, and picking Apply Edits tells iPRSM to make the entire batch of system revision edits for us. 14 of our selected systems now have open revisions, numbered 1.4, and in stage design. We stipulated that systems with revisions at stage submitted or higher should be omitted from the change stage edit, and so the stage of the last protected system remains unchanged. From design to audit to proactive management of change, iPRSM brings unprecedented accessibility, accuracy, and efficiency to pressure relief systems management. Brought to you by Curtiss-Wright Flow Control and Ferris Engineering.